Okay, so we're up to example 12 on the hypothesis testing worksheet. So like I said at the end of the last lecture, this is going to be another example where we have to test the proportion, but now it's going to be an example of a two-tailed test. So this way you've seen left-tailed, right-tailed, and two-tailed for proportions as well. So it says, according to the Centers for Disease Control and Prevention, the CDC, 18% of adults age 18 and over in the US smoke cigarettes. A medical doctor believes that the CDC is incorrect and decides to test this claim. The doctor took a random sample of 500 adults age 18 and over and found that 111 smoked cigarettes. Does this sample result support the doctor's belief at alpha equals 1%? So the population of interest are adults age 18 and over, and the parameter of interest is the proportion or the percent that smoke cigarettes. So that's P, right? And the assumption is that 18% smoke cigarettes. So the assumption is that the population proportion that smoke is 0.18, right? 18% as a decimal is 0.18. But this doctor comes along and says that the CDC is incorrect. Now, remember, incorrect is an indicator of a two-tailed test, right? Because the incorrect doesn't mean direction. It doesn't mean bigger than, more than, less than, smaller than, right? It's not a left or right-tailed test. Incorrect means different than or not the same as. So now I know my alternative, right? It's that the population proportion of adults that smoke cigarettes is not equal to or different than, right? 18%. So why don't we go ahead and set up our hypotheses? So step one, formulate the hypotheses. So the null is what's assumed to be true. So we're assuming that the population proportion is equal to 0.18. And the alternative is that the population proportion of adults that smoke cigarettes is not equal to 0.18. So there's my two-tailed test, right? So we have a two-tailed test, and I'm telling you to test at an alpha level of 1%. And we can even say in our head right now, right, what's the only way that we're going to reject the null hypothesis? If our p-value is less than alpha, right? And alpha is 0.01. So we're hoping that our p-value is smaller than 0.01 if we want to reject the null hypothesis. So let's go ahead and model the sampling distribution of the proportion. So let's just summarize the results that we got from our sample. So the doctor took a random sample of 500 adults. So N is equal to 500. And 111 of them smoke cigarettes. So X is 111. And now we can formulate P hat, right? So again, P hat is equal to X over N. So X over N is going to be 111 over 500. I want you guys to plug that in the calculator with me. So that's going to be 111 divided by 500, which is 0.222. So now let's label this normal curve. So the mean mu sub p hat is equal to p, and p we're assuming, right, in the null is equal to 0.18, unless we could prove otherwise. Now let's calculate the standard deviation of all the p hats. So that's going to be the square root of p times 1 minus p over n. So we're going to have the square root of 0.18 times 1 minus 0.18 over n, which is 500. Let's go 4 places. So I want you to plug this into your calculator as well. We're dividing by 500. So I'm getting 0.0172 for my standard error. So now we need our test statistic, right? We need to say, okay, where does our p hat, this 0.222, live within this normal distribution? Well, the mean is 0.18. 0.222 is bigger than that, so it's going to go to the right. So let's say that p hat equals 0.222 is right here to the right. So now we have to convert that to a z-score. So how many standard deviations away from the mean is this p hat? So we're going to say z is equal to the data value minus the mean over the standard deviation. Let's plug in. So we're going to get 0.222 minus 0.18. That's the mean. And we have to divide by that standard error that we just got, the 0.0172. So take 0.222 minus 0.18 and divide by 0.0172. We get about 2.44. So our z-score is 2.44, which means that p hat is 2.44 standard deviations above the mean. So let's label the curve in terms of z-score, right? So that z-score for the p hat is 2.44. And now we could calculate the p-value. And remember, this is a two-tailed test. So whenever we have a two-tailed test, you have to imagine this curve is a piece of paper. Imagine folding it down the middle. It's going to line up evenly on both sides, right? So if this z-score on the right is 2.44, this z-score on the left is going to be negative 2.44 by symmetry, right? So I have to shade the area in both tails. And my p-value is going to be the sum of both of those areas. Just like we did in the other two-tailed test for means. It's the same thing. It doesn't matter that it's proportions. So we have to get that shaded area. Now, both tails are the same, so just get the area in one of the tails and just double it, right? So I'm just going to get this value right here, the area to the right of 2.44. So we're going to come in from the left. So we're starting at 2.44 and we're shading up to E99. So let's go to the calculator. Normal CDF. So my lower is 2.44. My upper is E99. The mean is 0. The standard deviation is 1. And I get an area of 0.0073. So this shaded area is 0.0073, which means this area to the left is also 0.0073. And now we have to add them together. So the p-value is going to be 0.0073 times 2, right? Because I'm just adding it to itself. So let's take 0.0073, multiply it by 2, and we get 0.0146 for the p-value. So now how do we make our decision in step 4? We only reject the null hypothesis if the p-value is small enough, meaning smaller than alpha, right? Less than alpha. Now, is that the case? Well, what's my alpha level that I told you to use? I told you to use 0.01, which is pretty small. So is our p-value 0.0146 less than alpha, which is 0.01? It's not, right? 0.0146 is a little bit bigger. So since the p-value is greater than alpha, we fail to reject the null hypothesis. We don't have enough evidence, not strong enough. So what's our conclusion then? Well, we don't have enough evidence to support the doctor's belief, which is that the proportion that smoke cigarettes is different or not equal to 18%. So we can conclude that there is not enough evidence to support the doctor's belief that the proportion of US adults that smoke cigarettes is different than you could also say not equal to. I'm just going to say different than 18%. So there is not enough evidence to support the doctor's belief that the proportion of US adults that smoke cigarettes is different than 18%. We don't have enough evidence to support that claim. So this example wraps up all the examples that I have on hypothesis testing in terms of videos, in terms of live lecture videos. After this video, there is going to be another PDF with more examples on hypothesis testing and the solutions to each test. So it's not going to be a live video, but I will post another PDF of some examples where we have left-tailed, right-tailed, two-tailed on means and proportions. And I'll have the templates and I'll have all the solutions for you. So you'll have about another 6 tests to practice with. I'll do 3 and 3.